Today's webinar is Builder and Trade Perspectives, Challenges Meeting Insulation and Air Sealing Codes. We came up with this topic because a lot of our builders have been saying that they're interested in hearing more about risk issues that we're seeing in the field and more about best practices related to codes. We've been doing a lot lately with heating, cooling, and ventilation. Wanted to get more into insulation and air sealing since there have been some significant changes from a code perspective. And I happened to bump into J.R. Babineau at the Pacific Coast Builders Conference, and we got talking, and he was graciously willing to join us today and lead this conversation along with Graham from our team here at IBACOS. And what we're talking about today is really not solution dependent. You might say that Johns-Manville offers certain kinds of insulation and air sealing products. Yes, they do. But this is really just about general best practices and issues that we're seeing with building codes 2012 and 2015 from a national perspective, and then 2013 and 2016, what will be coming out in the newest version of the California Title 24 code as well. So JR will lead that discussion. Why we're talking about this beyond things that you've asked us for, in particular, if this isn't done properly, if you don't have best practices in place, or if you're having issues out in the field, it can certainly impact your ability to meet codes and also to meet some of those voluntary standards that you might be advertising to your home buyers. So it's certainly important to make sure that you're looking at this both from a quality assurance and performance perspective as well as a potential risk perspective. If things aren't done right, you happen to catch them out in the field, it can impact certainly your construction cycle time, which will hit your bottom line as well. Ultimately, we hope that your customers don't see issues later down the road, because that gets a lot more expensive. And then if you're looking at scalability, if you're currently doing 2009 code, or you're currently doing a lower version of code, and you're looking to move up to one of these new codes that we're going to be talking about today, really important to get your trade contractors in line so that you're scalable as the market is coming back, that you have the ability to deliver those performance levels and to meet the demand that you'll be getting in the marketplace. So really some good business reasons for talking about it. Again, J.R. Babineau and Graham Davis will be leading the discussion today. Really, J.R. is our primary presenter. He's been at Johns-Manville for 19 years. And is a very well-spoken building scientist, so we appreciate that for you for taking your time today. And Graham on our team, our Builder Solutions team here at IBACOS, is also a former trade contractor and builder himself, and he's out in the field on a regular basis with builders, seeing what issues that they're facing with their trade contractors and partners, and potential risk issues as well. So I think he'll be a good foil for JR's science rationale with what actually he's seeing out in the field. And JR has also done, and the folks at Johns-Manville have also done some voice of customer research, talking to their trade contractors to see what issues they're actually facing. So he's going to share some real snapshots from that voice of customer research with us today as well.
Okay. All right, this is Graham. Thank you, Betsy. Appreciate that, and I'm sorry that we did not realize that we had lost network connection on our end here. As Betsy said, I am with IBACOS, and I am with JR, an engineer with Johns-Manville, and here to talk about the significant air sealing and insulation changes that are taking place now and we're facing in the 2012 and 2015 codes. I have the opportunity to get out about every other week and tour around the country and meet with builders and help them with their questions and quality issues and performance issues. And JR, it is true that building enclosure changes and how to meet the air tightness requirements and changes in insulation is a real challenge that they're facing, and hopefully we can provide some answers today.
Well, I hope we can too, Graham, and you know, or at least I think we'll be able to certainly shed some light on some of the connections. You were saying that you get out and get to talk to builders, and I fortunately have had the opportunity over the last few weeks to talk with some insulation contractors who also do air sealing, some of really some of our good customers. And you know, these guys really describe themselves as experts, right? They really try to, you know, put themselves out there as experts in the area of air sealing and insulation. Most of them not only are installers, they also do blower door tests, they do duct blaster testing. A lot of them offer HERS ratings as part of their services. You know, they really do care about quality work, and they know what it takes to not only meet code requirements, but also to do beyond code programs like Energy Star or Zero Energy Ready Homes, right? These aren't just your kind of fly-by-night insulation in a pickup truck kind of contractors, right? These guys have been in this business for a long time and really know what it takes to do a good job. And what we really wanted to get a sense from them and talking to them was, what are the challenges that they're facing when it comes specifically to meeting some of these newer codes around and the requirements around insulation and air sealing. And it was interesting because they were very free to talk. You know, I would ask for a little bit of their time, and usually a half hour, an hour later, they're still going strong. And it wasn't just, you know, kind of grumbling about price pressures or things like that in the market that you would normally think, but they were really had a lot of stories to share about challenges that really relate back to the house as a system concept that we've all been kind of hearing about and preaching for many years, and really how this is key for them to be able to meet you know, these new energy codes, and it's just really becoming more, you know, more critical than ever, that not only for the insulation and air sealing guys, but to start pulling in some of the other trades. And so obviously I got a lot of different feedback. We tried to group it together into some kind of big buckets, and that's what we're going to talk about today is some, you know, some chunks of the code and how this relates. Let's see. Betsy, could you advance one for us, please? Thank you. And so, you know, so the big buckets, really, the biggest challenges going to be around air leakage limits. Right, the code is updated, and we'll kind of talk about this a little bit more next. But air leakage limits is really one of the big things we're going to talk a lot about. We are going to talk a little bit about increased insulation levels. Right, a lot of attics and walls have increased what their R values are, and you know, the other piece, the third bucket that we're going to really talk about today, ties into these other two. The increased restrictions on air leakage and the increased insulation levels really mean that there's a lot of different ways that you could get there, right? There's a lot of different combinations of materials and approaches, and this leads just to a lot of complexity, both at the builder and the installer side, but also on the inspection side. Go. No, Betsy, can you go forward one, please? Thank you. So,
well, let's start with the leakage limits. You know, for the past several years, builders have been using expanding foam as the silver bullet to try and get a tighter building enclosure. And as they are beginning to have to pressure test every home, they're learning a lot about what works and what doesn't work, and sometimes foam isn't really going to do everything that they hope it is going to do. And so the question is, what do you see as the key area of focus to take building tightness to the next level?
Sure. Yeah, Graham, that was a big piece. Betsy, can we go forward one? Oh, thank you. You know, yeah, this was really a big one, Graham, in terms of things that the contractors had to share with me, right? So I think intuitively we all understand that framing is an important part of air sealing and of establishing a good air barrier. But right, as we said, as air leakage limits move from something not terribly tight, right, 7 air changes per hour in the 2009 code was really, you know, kind of a standard that what I heard from contractors is they can get that pretty easily with kind of standard framing, caulk and can foams. They can get to 7 or even sometimes 6 air changes an hour without too much trouble, and even with some of the issues that they might run into with framing. But as we start to go to these tighter targets, it really just requires more coordination and more attention to detail from both the framer and the air sealer.
I doubt many builders consider the framer a huge part of the air sealing protocols. What significant challenges do you think they're facing?
So I agree. I don't really think they do, and I think hopefully this webinar will kind of help raise the awareness of the builder that the framing trade is really going to be where the air sealing begins, because it really is. And the real problem areas that I heard from the insulation contractors and the air seal contractors were things like connected spaces, right? If we have cantilevers, soffits for cabinets and other things, any of these connected spaces that tie into the building enclosure but really shouldn't be part of it would be one big area. Porch attics, right? The photograph all the way on the right that I borrowed from the Building America site, right, really shows a good example too, where we've got this big open space connecting into a porch attic. It really should be blocked off, right? We can air seal this wall all we want, but if that big hole is there, there's just no way to stop huge amounts of leakage from going through there. Another area that the installers really talked a lot about, and if you kind of this upper left photo, would be band joists, right? In particular, where the floor joists are parallel to the foundation wall, quite oftentimes the joist spacing ends up with some odd, less than full width cavity, and oftentimes that just ends up going at the end. Well, that is a really tough spot to get up into. We've got the foundation wall itself that eats up some of that space, and then for the air sealer to try to get up into there and air seal that space can become almost impossible if that's not a full width cavity. One of the specific requests that an installer passed on to me was, if you have to have an off width cavity, drop it in the middle somewhere, right, or at least bump it in one so that that last cavity is also full width, and then they can actually get in there. We already all know that band and rim joists are a real challenging area to air seal and insulate, and having it be less than full width really just compounds that. And finally, one of the last big topics that came up, and this kind of ties to this bottom corner, is something as simple as cleanliness. We need to remember that our air sealing is done with caulks and adhesives and sealants and foams, right? These are all goopy, sticky chemicals, and they don't stick well to dirt. They don't seal well around dirt. And for them to work, they really need a dry surface. And the simple truth is that when an air sealing contractor gives you a bid to air seal the house, it doesn't really include cleaning up after the guys that came before, right? They're assuming that they're walking into a clean site to begin with and can just start going. 1 or 2 times, they're usually willing to, they'll just jump in there and clean it up and take care of it. But, what I hear is after a while they kind of stop doing that, right? And you kind of see this photo on the left where some caulk has been laid down, but there's all kinds of debris there as well, and that just happens, and that you may or may not get through the initial inspection with that, but long term that's obviously not a situation that we want to have going on in the building.
I think I've even seen lines of expansion foam run over the tops of mice and crickets and whatever other critters were in the way. So
I don't doubt that at all. Betsy, we can go forward one.
Yeah, these changes, they sound easy, and when you talk about them, you throw them to paper and all, but having been in the home builder environment, I know that even doing something as simple as trying to roll out flashing panels and making all the trades responsible for flashing any hole that they put in the building enclosure, it's unbelievable what what a challenge such simple changes seem to be, where does the builder begin?
Well, and I think everybody's going to see that this will be a recurring theme in our webinar today. But I mean, it really starts with, I think first, just the builder recognizing, like we talked about earlier, that framing, especially now and moving forward, is a key piece of successfully hitting insulation and air sealing goals in the code or beyond code, right? So really understanding how the framing impacts these other things, and just making sure that we've got clear statements of work that are just in the construction documents, right? We need, the framers need to know what they're responsible for, like this photo on the right that shows, right, a rigid air barrier separating this little porch attic from the rest of the wall, right, that there's details, right, specific details in their construction documents that show all of these things. And yes, that takes some work and that takes some learning curve, but being aware of that is important. And I think, beyond then starting with the builder, but then moving on to the framer, right, the framing crew needs to understand that there may be changes, right? They may not be able to just frame the way they've done for the last 10 or 15 years to be able to meet these new codes. And of course that obviously ties into framing labor, right? The framers themselves need to know, and of course that means that any framing crew that shows up on the job needs to know, right? I've heard stories of, one framing crew is really good, but they're not always the ones that show up,
yeah.
Right? You could easily get, in any given week, a different set of guys, and if they all don't know, suddenly what was being done well, the different set of guys shows up and now it's not done well, right? Now there's holes and problems.
Never-ending battle.
Yeah, I think it's, and I think then connecting it too, right, it's not just all on the framer and the builder, right? It's also the air sealing and the insulation contractor. I think they need to recognize and communicate well back to the builder that, when they're bidding something, here are the assumptions that are baked into their bid, right? If that needs to be different, then there should be a conversation on that, right? Maybe the air seal contractor does need to include more in their scope of work that they might not have in the past. But again, communication I think is key to that.
Yeah, I think that scopes of work is a document that has not received the respect that it needs to receive. Builders have quite frequently used some very generic templates of scopes of work because, it's probably because they do lack respect, and if the builder isn't upholding the scope of work as their Bible for how they are going to build a house, then the trade isn't going to uphold it as any more of an important piece of the process than the builder themselves. And when trades do recognize that there is a conflict between building plans and the scopes of work, they will typically default to the plan. That's what they're held accountable to, is the plan.
Mm-hmm.
And all too often, architects will drop in library details that are stock details available to them. That I still see a lot of details showing wood windows on houses that have been for a builder that have been doing vinyl windows for a decade. It's like. Really, we need to update these construction documents and these plans, and making sure that they are in alignment, the scopes align with the plans, and that there is good, clear communications and very clear expectations that are laid out in the scopes of work, and that are very clear in these construction documents. So let's talk about some of the other changes.
Mm-hmm.
The other challenges, rather, framing details that need to be considered.
So, yeah, I totally agree with you, Graham. And the next one that we're going to talk about, and it's still tied into air sealing, but we broke it out because it is such a challenge, and that would be knee walls and what we're calling ceiling changes, right? Architectural ceiling features, right? So this really. It warrants its own topic because it comes up so often. I mean, literally to a man, every contractor that I spoke with talked about this being a challenge. And again, right, the photos are just some stuff I grabbed from the Building America site, but we'll see some other ones in a minute. And, you know, it's really important because, you know, they're popular, you know, they're common, we see them all the time, and the real challenge here is in providing really six-sided cavities, right? These, you know, if we think about what a knee wall is doing, it's insulating between the conditioned space and the attic. And, you know, honestly, attics can be a more severe climate than the outdoors, right?
Oh,
especially, right, if we're in any sort of a climate where it gets warm. You know, outdoors it might be 90, the attic might be 120, and so you know, these areas really need good air sealing. They need to be insulated well, and the insulation needs to really be enclosed with rigid backing, you know, all the way around.
I have recently spoken with a builder who had firsthand experience on his own home when he was really understanding the importance of the six-sided enclosure on an attic knee wall. His wife had approached him about a very uncomfortable bonus room that they had upstairs that just could not cool off. And when he peeked up into the, he got up into the attic in the garage and took a look at this attic knee wall, saw that it was just open insulation on one side. So he went through the process and created a six-sided enclosure on that, got it nice and sealed up, and the temperature in that room dropped an average of 10 to 15 degrees. It was really impressive. But, you know, so often I see these attic assemblies, these attic knee walls are just framed using a gable end truss. So you've only got 1.5 inches of wall thickness to work with, which you can't build a properly insulated and air-sealed cavity when you do that.
Yep. Betsy, can we go to the next one, please? Yeah, Graham, I totally agree. And, you know, and tied to knee walls would be architectural ceiling features, right? If we look at this photo on the left, this is a home.
I'm sorry, can you pause for 1 second? We just got a question that might be timely and best addressed now. Sorry about that. Someone just asked if you can give an example of a six-sided enclosure.
Sure. So a six-sided, so actually we can, even though it's got big holes in it, if we look at this photo on the right, a six-sided enclosure would be, well, they would also need to cap that, wouldn't they? So that's still not going to be quite six-sided. But if we look at this knee wall in the photo on the right, using a rigid material like they've used, looks like thermoply, to face the attic side of this bonus room. And then, of course, they've got a bottom plate on the, you know, on the knee wall. They'll put drywall on the inside, and then they should actually have a top plate, right, running across the top of that knee wall as well. That's when we say six-sided enclosure on a knee wall. It's truly making a six-sided box for that insulation to be inside of, and then, of course, that six-sided box should be air sealed as well.
Another common place where you see it missed is on a drop-in tub deck for a big soaker tub, where you've got it sitting on an exterior wall, and before the tub gets set, you're looking inside that tub deck, and if you're looking at insulation, that is what needs to be addressed. So that needs to get a rigid thermoply type of sheathing sealed and fastened over that to create that six-sided enclosure.
Yep. So, oh, sure. Again, tied to this, right, the photo on the left is, and I don't know, you might not be able to see my pointer, but Betsy's kind of highlighting these surfaces. So this would be an architectural ceiling that, you know, when it's finished is going to look beautiful, right? It's going to be this double tray ceiling in the living room of this home. And of course it looks beautiful and homeowners love it, and you know, it's one of these features that's really working its way into, right, not just move-up homes, but you know, even some nicer starter homes. And I think it's important to look at this and go, well, how do we insulate that properly, right? I mean, yes, you could drywall that in and you could air seal the drywall side of that, right, the ceiling side of that, more or less. But to try to insulate that properly from the attic, can be a real challenge, right? We don't have six-sided enclosure, and I don't even know how you would really get there. You'd almost need to put up some big blocking so that you could fill it, right, really deep with loose fill to attempt to get, proper amounts of insulation on all of those sections. And again, this is a real challenge. And the photo on the right, kind of the real purpose of that photo is to show that even when we do put things like rigid backing in a knee wall, it needs to be air sealable, right? There's some pretty big holes. I mean, the red mud aside on that thermoply, right? We've got some big holes there. We don't have top plates on this knee wall, and so to really air seal this bonus room, and this is actually a room over a garage, similar to what Graham was talking about earlier, but it's going to be a real challenge in southern Alabama for this room to be comfortable, right? It's going to be really hard, right? I mean, it's going to tend to be a really hot room all summer long.
JR, let's go back to that question just for a minute, because it may not be entirely clear why the six-sided enclosure is such an important assembly. What is taking place in there when you've got a vertical wall assembly with insulation stuffed into it but wide open to an unconditioned environment on the other side? Why is that so important? Why does it make such a big difference?
So that's really a good point, Graham, and I think what makes a big difference there is that, especially because the insulation we're putting in there is probably going to be fiberglass or cellulose, something that is air permeable, right? Air can be pushed through these materials, and what will end up happening is, right, that hot attic air can very easily get drawn into that wall, and then especially in the holes that we see here, right, it could get drawn in low and then vented out high, and so by pushing air through the material, we've really kind of eroded it's not able to do its job, right?
Which is to create dead air space.
Exactly right.
So what we are doing is creating air filters.
Yeah, exactly. That's right. It acts as an air filter instead of creating a dead air space. Betsy, if you advance to the next slide, we'll kind of see, the other side, right? The good things, right? The photo on the right shows a knee wall that's actually been done well, right? So we're able to see the knee wall. That's where the backing is that we can see, blocking off that wall space. We can see canned foam has been used to seal off, right, where joists come in, where surface penetrations go through, right, that whole space is sealed. There's a top plate on that knee wall, right, so that when we insulate that space and then finish it on the interior with gypsum board, right, it's really going to be able to do its job. Another way to kind of maybe work around the challenges with air sealing and insulating, sealing features and knee walls is, of course, to bump the insulation and the air sealing layer out to the roof deck, right? And we can create what we call an unvented or a conditioned attic. And the photo on the left would be kind of one example of that, right? This is a bonus room, again, where we can see somebody's used close-cell spray foam in this case to both air seal and insulate this space, so that then those attic spaces aren't, the brutal 120-degree, conditions that we would see otherwise in a conditioned attic or in a vented attic. Of course, that can bring some other benefits around HVAC ducts that we don't even have time to get into that today, but there's other benefits for that too. Can we go ahead and jump to the next one? Looking at the time, we're going to jump onto the next one. So the other kind of one of the other big buckets was just around improved insulation, right? We kind of showed in the slide anyway how a lot of the newer codes are requiring increased insulation levels both in attics and in walls. And, this is, again, where framing really can play a factor. Things like how much framing is used in corners. You got the photograph there on the right where there's, I don't know, about 7 or 8 studs put in next to that door. Another good example would be this drawing in the middle, right, where we have interior partition walls, right, connecting with the exterior wall. All of these are areas where Lots of times extra framing gets used, and where framing is, insulation is not, and so it can become a real challenge. Of course, builders know that optimized framing can be a real cost savings measure, but again, I think it gets back to the construction standards that are used and making sure that we that we're holding to those. Next slide, please. So, so like we had said, right, best practices would be things like, 2-stud exterior corners so that we can actually insulate, all the way out into those corners. This middle photo here on the bottom shows a good example of ladder blocking where an interior wall can join up to an exterior wall, but we get to keep our, pretty much full insulation levels. And then also things like insulated headers on the right where and there's a lot of different varieties and flavors of an insulated header. This particular one, right, enables the builder to use a netted bibs blown-in fiberglass system. But of course, foam boards and other things are used a lot for that.
Yeah,
as well.
I see a lot of half-inch EPS or XPS foam being sandwiched in there, and the corners, which are also commonly called California corners, which is the only place I never really see them. When I was a framer, I got started in this business almost 30 years ago as a frame carpenter, and we had a mantra: when in doubt, add a stud. I mean, you just can't make a house, too strong. So we're adding studs, and it still seems that you're seeing that a lot in the field these days. But that's a bad mantra. It's not going to work in the high performance house.
Yeah, that's a good point.
Next slide, Betsy.
Sure.
So the last kind of bucket that we want to talk about before we move on into future stuff is really around inspectors and inconsistency. And I'm sure this is not unique to insulation and air sealing, right? I'm sure that any builder kind of struggles with, depending on the inspector, you might get somebody who's looking for different things. But in particular, the energy code really has got a lot of kind of fuzzy areas that are open to interpretation. And of course, with interpretation means opinions, right, and differing opinions. And so really some of the frequent comments that I heard were related to things like alignment of insulation with the air barrier, right? And in California, it kind of goes a step further where they have something called the QII, or the Quality Insulation Installation Credit. And so, I think we all understand that insulation needs to be, not have gaps, voids, compression, right? And needs to be in contact with an air barrier. And it's pretty easy to put that on paper in words or in drawings, but it ends up being kind of a different animal once we end up having it be in the field and somebody's looking at it. And so, I think that piece was something that came up often, is just, differing opinions from differing inspectors. And it kind of adds to this challenge is honestly the internet, right? And the knowledge that's available online, right? And there are a lot of good sources of information for building science topics and topics like we're talking about today. IBACOS and the Alliance would be one good resource. A lot of manufacturers can be good resources, right? And there's a number of us out there that really work hard to make sure the information that we put out there is accurate and up to date. But there's other sites, right? There's blogs and other places that aren't necessarily so up to date, or that may have some pretty strong biases one way or the other in terms of favoring one particular material over another, or they could just be wrong, right? And an experienced and knowledgeable reader can filter those out, but oftentimes, a busy inspector is not always able to do that. And sometimes, reading somebody's latest blog post, I actually heard specific examples of this, that, they'd have an inspector come out one week and one thing was good, and he reads something online over the weekend, and suddenly the next week, his opinion is all changed, and that may or may not always be justified. So that's is certainly a challenge. Betsy, go on to the next page, please.
Sure.
And of course, biases and pet peeves and opinions, we're not going to magically make that go away today, unfortunately. But I think it's important to recognize, you know, that these guys are people. They're out there trying to get information, and they're going to bring some of those biases in. And I think you know, really the way to address that is recognizing it, right, and bringing those folks in, getting them involved more at the design and planning stage, you know, really helps mitigate that, right? Understand what their pet peeves are, understand what they might be looking for, and I think making sure that both the framers and the insulators know, you know, these are some important pieces that we need to really focus on, right, especially in a given jurisdiction. I think that becomes an important piece.
And the inspector is not the enemy.
No, no, they're not. I think we're ready for the next slide, Betsy.
Okay.
Which maybe questions.
It is. Hey, I thought that was about time. We do have a few questions in the queue, shockingly enough, one of which I'm going to take myself. And then I will float the other two to you, and forgive me, one of them I'm not sure if it's directly relevant and how it's connected to what we're talking about today, but you guys can let me know if it's something that you're able to answer or not. But the first one that I'm going to take myself is actually from one of our attendees today, who I think is on the manufacturer or government side, probably looking themselves at a lot more advanced building systems, a lot of the stuff that we do, you know, as a group to look towards zero energy, and asking if this is rebroadcast of a webinar because we started with 2012 and 2013. You guys can correct me if I'm wrong, but if you go to the energy.gov website, you can see a really nice colored map of the code adoptions for energy codes throughout the U.S. And there are a lot of areas that are still on 2009 or not on 2012 yet. And even with the areas that are on 2012, certainly all of California is on Title 24. But I think the intent here is both what are some of the challenges if you're already building homes to these code levels that you might have seen yourselves and maybe not known what the root cause of them was, or if you are looking to move from 2009 to 2012, 2013 codes, what do you need to be aware of? So that's the first part of this session today. So it's a little bit of proactive if you're moving up from a code level, and a little bit of risk management, quality assurance, and awareness if you're already building to those code levels. So that's really why it's still timely. And then the second half that JR and Graham will get into in a little bit is 2015, which, if I'm guessing correctly, I think there's only a few states in the country that are currently on 2015 IECC code. And yeah, like Maryland and I don't know what the other one is, but I think Maryland.
Rolling it out.
Maryland is one.
Okay.
I don't recall now the other one, but there's two for sure that have enacted it.
Yeah, so there's only really a few states that are at that level. And then the other thing that they'll be talking about is 2016 California code, which of course will be rolled out soon, but to the whole state. So that is the future looking, as JR said, part of the discussion. So I hope that clears that up. You got a very good, oh, somebody said Vermont is one of the other states that's 2015. Thanks, Mike. Yes. But that's why. So I hope that clears it up and makes that make sense to you. You guys also got kudos for your explanation of knee walls earlier. Just wanted to do that with you. And then two questions here, one of which is a softball that I'll throw to Graham, and then the other one I will throw to both of you to see if either one of you knows how to answer this, because I'm not sure. The first one is, does IBACOS have a library of scopes of work for builders to use, something to start? Maybe they would incorporate some of the best practices and give the builders somewhere to a jumping off point.
We don't have a library posted that online that is free information that they can get. We certainly we develop construction standards for builders, and our are able to help them with those. But there are some good resources that have been made available. One of them that comes to mind, of course, is the EBA Builder's Guide that was produced also through Builder Science Corporation. Has a lot of great details that they can resort to.
Mm-hmm. And from I'll chime in on that front as well. We don't have the open library, but we do have some best practices that we've developed, and as you said, we have the ability to customize something for a builder if they're looking to put together a package of standards. So, we do have a bit of stuff in our back pocket. It would just really depend on what you guys are looking for as a builder. So, thanks for that, Graham. And then this other question, I will read to you and let me know if it's something we can answer now or if we should address it offline. What's been your experience with HVAC systems causing homes to go under negative pressure? And what are some remedies to this?
Wow. I mean, we could probably burn up the rest of the time talking about that. I mean, it certainly happens. I mean, I think in the interest of time, I think the short answer is, right, the remedies are good duct sealing, really good duct sealing, and then good air sealing for the building enclosure, right? I think if we seal those paths off, we'll be less likely to encounter problems.
Well, just real briefly, also you showed one slide of a conditioned attic space, which is, as you mentioned, one way to get your entire HVAC system inside the building enclosure, which is going to do a lot towards eliminating that potential.
Yeah. But there's honestly, right, beyond those kind of short answers, right, there's a laundry list of best practices around duct design and layout and installation that will help avoid some of those issues.
Yeah, and I'll keep that question. We've done a lot, as I mentioned at the beginning of the call, we've done a lot of webinars related to heating, ventilation, and air conditioning. And the last one that we did was related to comfort issues, so I'm not sure if we touched on, that at all, or if it's in any of the reports that we've done or best practice guides that we've put together for the Building America program. But I'll float that question to, forgive me, whomever posed that question. I will float that to the team and see if there's a resource or a couple of things that I can direct you to in response to that question. So we'll see if there's anywhere else we can help you on that front. That's it for questions at the moment. Oh, and the person who asked that said thank you. And we'll just keep moving then and try and close close to where we originally started. And thanks again for your patience as we were ramping back up earlier during the session. So I'm going to make the executive decision to move forward to 2015 and 2016.
Yep. Yeah, thanks, Betsy. Darryl, we've talked a lot about the bricks and sticks challenges regarding framing and to improve a home's air tightness and thermal performance. This next section, let's talk about some of the biggest changes builders are going to look at and are facing in these code changes.
Yeah, I think that the big ones, Graham, for the upcoming stuff, and of course, as we talked about in the Q&A, the 2015 IECC code is actually already out there. It's not more of a future thing, and a couple of states have completely enacted it. There are a number of other places that you mentioned in Texas and others that are planning to put it into effect here soon. And I think one of the biggest changes there, and we'll talk about that more in a second, is that they have a new compliance path called the Energy Rating Index, which looks shockingly like a HERS index. And so we'll talk about what that might mean. And then in California in particular, they've really made, for this next 2016 version of Title 24, some real pretty significant changes, and we'll, around attics and walls, and we'll dig into that a bit more as well. Next slide, Betsy.
Okay.
So on the Energy Rating Index for the compliance path for the 2015 IECC, what that basically allows a builder to do is use a HERS rating or HERS index or an equivalent to demonstrate energy code compliance. And so what that really means is they're going to have a rater or somebody trained as a rater that would be going in and doing the inspections and doing the testing, and and their documentation is going to be used back to show and prove energy code compliance.
So that takes some of that decision process out of the hands of the regional inspector. They're just looking at the documentation of the rater.
Yep, exactly.
Very good.
Right. Yeah, yeah. Next slide, Betsy.
Sure.
So, I do think that can be a good thing, but I think, it can go, it poses a potential challenge, right? I mean, we need to remember that the code is not the same as, as the HERS standard, is not the same as programs like Energy Star or the other things that might also use a HERS number. And so, I think it's just something that we need to bear in mind, right? Raters, I think lots of times, one, they're very knowledgeable, and so that's a good thing, right? They usually have a good grasp of building science, a good grasp of what makes a building energy efficient or not. They were required to do continuing education, and so those are all good things. But of course, right, again, HERS inspectors, like any other inspector, right, they are going to have a lot of their own opinions, and honestly, a lot of times, right, they may be seeing homes that are above code, right? I mean, I think lots of builders that might rate every home, they're probably building a little bit better than code anyway, and so I think there's going to be could potentially be a disconnect sometimes, right? A HERS rater goes in, to do an inspection on a home that's really just intended to be code compliant, and so they may expect to see things that they don't necessarily. And so, to me, it kind of ties back a bit to the pet peeves. I heard a lot of anecdotal stories. Some are kind of pretty bad that I think can, tie into things like quality, QC, even on the rater side, right? And I know, there's a lot of companies out there that provide that kind of service too. But I think it could present some challenges.
Well, it still always comes back to good communication, and a mistake I see a lot of builders make is not involving the inspector or their energy rater in the initial design processes to where they can make sure they're all on the same page about what is going to be a compliant or non-compliant assembly. So communication, that's very, very important.
Yeah, next slide, Betsy. And that kind of, the next slide really hits to that, right? That's exactly right. I think just like with, code inspectors, for 09 or 2012 codes, HERS raters as well, right? They really need to be brought in and included at the early stage, right? Whether that's, that can be in construction documents, if there's any sort of mock-ups that are ever done, right? Anything that they can kind of weigh in to say, I want to see X and I don't want to see Y, and so that everybody is just aware up front. Yep. Next slide.
There's a rather enormous change coming that is first going to impact builders in California, as mentioned, to meet the changes to Title 24. You want to give us some more detail on that?
Yeah, so we'll give a quick kind of preview of Title 24 for anybody building in California. And the big changes here are going to be, well, so first off, these changes, we got a little bit of time, right? So these changes are due to kick in, I believe it's January 1 of 2017. So we've got a little under 18 months for us to all kind of get our ducks in a row for this. But really it means we need to start now, right, so that we can work out all the bugs. The big changes here, the first one is what Title 24 is calling HighPerformance Attics. And that kind of ties with ducts in conditioned space. So either attics are going to have this new higher level of insulation required, or we'll need to put ducts into conditioned space of one type or another, and we'll talk about that more in a second. The other piece is what they're calling high-performance walls, which really is going to be focusing more on the U value of a wall, which, if we recall, is kind of 1 over the R value. But we'll talk about that more on the next slide too. So if you could advance this one, Betsy.
Mm-hmm.
So to hit more on the high-performance attics, basically what California is saying is that if you are building and you put your ductwork and your HVAC equipment up in the attic, and it's a traditional vented attic, they are now going to require not only to have a minimum of R38 down on the attic floor, but you will also be required to have R6 or better insulation up at the roof deck. And so it seems a little backwards, I think, to a lot of us in the building science community that we would have a vented attic but still insulate at the roof deck. But the work that the California Energy Commission has done kind of shows that there's still a cost benefit there, especially in terms of heat getting to the ductwork, right, is really what this ends up being all about. The alternative to that is we can take the ductwork and put it into conditioned space. So the middle photo on the slide kind of shows, right, one example where a builder has boxed in a soffit on the interior of the house where all of the HVAC equipment and ductwork is put. And of course, another option to that is what we talked about before, where you could just create an unvented attic, right? Bump the insulation and the air sealing out to the roof deck. Again, the photo we have here shows spray foam. California actually will allow you to use fiberglass or other insulation materials as well up under the roof deck, partly because they're warm and dry predominantly, and there's a lot of tile roofs. So they've kind of taken the step to say you can use that approach.
I've seen it done a lot in the Arizona market with netted and blown fiberglass insulation. Do you think that when it's all said and done and you compare these two options, the cathedralized or the unvented attic may turn out to be the winner of the two? Or?
I would suspect yes, and I think that's really where, I guess this is my opinion. I've got no official word from the California Energy Commission on this, but I think where they're trying to really push people is to get ductwork into conditioned space, one way or another, right? I mean, right? If builders already do something like this middle photo, then no problem, right? They don't have to do anything different. They can just do a regular vented attic with loose fill on the attic floor, and off they go. But I think what they're really trying to do with their goal, obviously, of being zero energy or zero ready for their energy code in California, and they recognize that that the energy penalty from ductwork being in a hot attic is just something that they've got to get away from, and so that's really what's driving a lot of this.
Yeah,
absolutely. Next slide, Betsy.
Mm-hmm.
So the other piece, the other big issue, the new change is what they're calling high-performance walls. And basically what the new code is saying is their baseline construction, they're saying is going to be, and it's this top row on the table, is a 2x4 framed wall, 16 inches on center, with our 15 cavity insulation and our 8 continuous insulation on the outside. So that gives you a U value, if you account for all the framing, thermal bridging effect, of 0.050, right? That's a heat flow number, BTU per square foot per hour per degree. We don't need to necessarily worry about the units, but this U value of 0.050 is basically what everyone has to meet. But how you get there is completely up to you, right? So what this table includes is information I pulled from a workshop that was done at the CEC a while back when they were developing this code, trying to show that there's a lot of different ways to achieve these numbers, right? You could do 2x6 framing with R19 and R6 continuous insulation. You could do R21 with R5. You could do 2x6 advanced framing, so 24-inch spacing. Again, you could do R19 bats with R5 on the outside. And of course, when you go to more advanced framing techniques like staggered studs or double studs, those kind of get you there pretty fast. Of course, depending on how a builder builds, though, these things can all include a learning curve, right? If there is a significant change made, if a builder's not used to using continuous insulation, right, all of these things can involve a learning curve that could present some challenges at the beginning.
Yeah.
Obviously, once you've done it, once a crew has done this a few times, they sort the bugs out pretty quick. Right?
Yeah. I've been visiting builders in California over the last 10 years and have watched the trend to this one-coat stucco system with the an inch of EPS foam on the outside really has taken off there. So this is kind of a nice step towards meeting this. Of course, if they are trying to achieve that that top line, they're going to have to step up to a full 2 inches of foam to do that, which offers some real challenges with window installation and whatnot. So sticking with the one coat and an inch of foam and maybe going to a 2x6 frame might be the most cost-effective way for them to achieve that goal, but that's just a guess at this point.
Yeah, exactly. Next slide, Betsy. We're on to the last one.
So let's review these challenges.
Yeah. So I mean, we've talked about a lot of things, and we certainly appreciate everybody hanging in with us beyond our original end time. I think what we've really touched on are two big things, right? One, the first is that this notion of house as a system really needs to include framers, right? We've kind of talked about this a lot, and that insulators need to think of the house as a system, or insulation and HVAC guys need to understand, and builders need to understand how that works together. But now at the level that we're at with the codes today and coming soon, it really includes the framers as well, and it needs to. And so, more of these groups need to be talking to each other. This of course ties into things like scopes of work, and then communication, right, being the other piece. These things really all tie together. Good communication between the builder, the framers, the insulators, and the building inspectors is really going to be key, in making sure that everybody understands where they're going and how they're going to get there. Is going to really avoid a lot of delays, right, and recognizing that a little bit more time spent up front is always going to cost less than change orders out in the field, right? I mean, everybody hates that. Right, builders hate it, insulators hate it. Nobody likes to have to do change orders in the field or put out fires. And the more upfront work done, the less we run into those problems.
Absolutely.